Hi, my name is Naman Bansal. I'm working as a software developer at Adobe, and in this video, I'm going to talk about linked lists, how they're made and how they can be modified. So, a linked list is a collection of objects called nodes that are randomly stored in the memory. So, let's say this is a linked list and it has three nodes. This is node number 1, this is node number 2, and this is node number 3. And all these nodes are assigned some random memory locations in the heap. So, let's say the memory location of this particular node is 120. Similarly, for this one, let's say it is 100, and for this one, let's say it is 112. Okay. Now, next point, a node contains two fields, that is data stored at that particular address and the pointer which contains the address of the next node in the memory. So, basically, this is the very first node and it has two parts. The first part contains the data of this node and the other part contains the next pointer, which is nothing but the value of the next address in the linked list. Okay. So since this address is 100, this node is stored at a memory address of 100, we can say that the value present here would be 100. Similarly, for this node, the value of this next pointer will be actually the memory address of the next node, which is 112. So we can say that the value present here is 112. Okay, now the next point says that head points to the first node. So this is the very first node and this is the head. So basically this head is nothing but a node star pointer, and the value at this head is actually going to be 120 because the memory address of the very first node is 120. So the value here will be 120. Okay. Now the last point, the last node of the list points to null. So this is the last node, and as we know that this is going to point to null, therefore we can say the value present here is actually null. Alright, so let's look at the code now. The very first thing that you need to do is create a structure or class of the node, and that is exactly what I've done here. So I have a structure of the node and it contains two parts. The very first part is the data part and the next part is the next pointer, which is of the type node star and it initially contains null. Okay, now let's jump on to the main function. The very first line in this main function says that node star head equals to null. Now what I mean by this is that we have created a pointer of the type node star. So we have node star and it initially contains null in it. Okay. Now this is the complete linked list that we have here and it is completely empty right now. So let's try to insert some values at the very head of this. So we call a function insert at head2, which is this function. In this function, let's look at the formal arguments that we have here. The very first argument is node star ampersand headref. Now what does this ampersand means? This ampersand means that we are actually passing this value of head as a reference, not by value. So basically we'll have a head ref here, which is nothing but an alias of this head, and both of these are actually pointing to the same entity, which is this null. Okay, the next part is int value, which is passed by value only. Okay, so the very first line in this function says that node star temp equals to new node. What we mean by this is that we are going to make a pointer of the name temp of the type node star. So we have temp, it is again of the type node star, and it is assigned a memory. Let's say this memory is 120. So this one temp contains 120 right now, and it has some memory which is the data part and the next part which is initially given a null value. So it has null in it. The next line is temp data equals to value. Now what does this arrow operator means? This line is actually equivalent to star temp dot data. So basically this star means the value of this particular container. So this temp right now has 120, which is this address. Okay, so go to this address and take the data value in it. Okay, this complete part can be written as this arrow operator. So temp arrow data means that go to the memory address that temp has and then take the data part in it. So we need to update that data part with value which is passed as 2. So this data becomes 2. Okay, the next line says that temp next equals to headref. So go to temp, take the address it has here, which is this value, and go to the next part of this and update it with headref. Now headref is pointing to null only, so therefore nothing is updated. The next line says that headref equals to temp. Now temp is 120, so we update this by 120 and after that we return. Since we are returning now, we don't have this temp anymore. Okay, so let's remove this. Now this headref has 120 now, which actually means that this is now pointing to this node. Let's go to the next line, which is insert at head 4. Again, the same thing, we have a pointer of temp. This again is of type node star, and let's say this address is 112. Okay, now this again will have a data part and a next part which will have null here. Okay, now the very first line says that temp data equals to value, which is 4. So we write 4 here, then temp next equals to headref. Temp next is actually equal to headref now, which is 120. And what we mean by this is that this pointer, this node is going to point this node now. Okay, then we have headref equals to temp. Now this is headref, which will now be equal to 112. So let's update 112 there, which actually means that we are going to break this bond now and make a new bond, which is this. Now head is pointing to this node, then this node is pointing to this node. Therefore, we can say that we actually inserted a node in the head. Okay, let's go to the next part, which is insert at head 1. Okay, now again the same thing. We create a temp pointer and it is assigned some memory. This is the data part. This is the next part, which is equal to null. Let's say this address is 110 now. Okay, now temp data equals to value, which is 1. So this value will become 1 now. Temp next equals to headref. So this is 112. So we update this by 112, which actually means that this node is going to point to this node now, because 112 is the memory address of this node. Okay, then we have headref equals to temp. Headref will now be equal to temp, which is 110. So we have 110 here, which actually means we need to break this bond and make this new bond, which is head pointing to this new node. Okay, and then we return. So again, we remove this temp value and this is also removed. Okay, so as you can see, we have actually created a linked list with 3 nodes. This is the head part, which is pointing to the very first node. Then we have the second node, and then we have the third node. Okay, the address of this was 112 and the address of this is 110. Okay, so now that we are done with inserting values at the head, let's try printing the linked list. Let's go to this function now. The very first thing that you need to see is the formal arguments, which is node star head value. As you can see, there is no ampersand here, which means this value is now passed as pass by value. By this, we can also say that we actually created another head val pointer of the type node star. Okay, and the value this will have is actually going to be equal to head. Okay, this is 110. But since this is now pointing to a different entity, therefore we can say that any updates made in this head value will not be updated in this head. Okay, since this is 110, we can say that this is going to point to this first node. Okay, now let's look at this while function. So this while function says that while head val is not equal to null, we need to keep on going and print the head val data. So head val right now has 110 in it, which is the very first node. So we can say that go to head val, which is this node, okay, and then take the data, which is 1, and print it. So we have 1 here, and then we print arrow. So this is printed. Then make head val equals to head val next. Okay, head val next is 112. So this will now become 112, which means that this is now pointing to this node. Okay, then again the same thing, print head val data, which is head val data, which is 4. So we print 4 and then again make arrows. Okay, then we update head val with head val next. The next of this head val is 120 right now, so we update this with 120. Okay, now the same thing goes on. This means that it is now pointing to this pointer, this node, and we print head val data, which is 2. We again print this. Okay, and then we say that head val should become equal to head val next. This next is null now, so we update this with null. Now in this while condition, we see that head val is actually equal to null. Therefore, we come out of this while loop, return, and then we return out of this function, and that's it. So as you can see, we were able to print out the complete linked list, which was 1, 4, and 2. That's it for this video. In the next video, I'll talk about deletion in a linked list and I'll consider all the cases of deletion. Now, if you like the video, make sure to subscribe to the channel and also comment down below if there is any other topic you want me to make a video upon.